Today, we're diving deep into the physical hardware that's actually powering the AI boom. No, we're not talking about software or algorithms. We're talking about the pipes, the plumbing, the absolute bedrock of our AI future. And believe me, it's a high-stakes race.
So here's the question that's driving a multi-billion-dollar tech war right now. What do you do when your AI model gets so huge, so incredibly power-hungry, that it literally can't fit inside a single building anymore? Well, what happens is you run smack into a massive, industry-wide bottleneck. Suddenly, the links between your data centers become the weakest link in the entire chain, and that threatens to grind the whole AI revolution to a halt. And that's the problem we're going to unpack. To really get a handle on this, we've got to start with AI's own growing pains, because the scale we're talking about is creating some serious problems that you can't just throw money at to fix. I mean, just think about it. These giant AI clusters are hitting hard, physical walls. They are literally running out of floor space in data centers. They're trying to suck down more electricity than local power grids can even provide. And the heat they generate, it's just overwhelming the cooling systems we have today. So, the industry's big idea, their solution, is a new strategy they're calling scale across. And it's pretty simple, really. Instead of trying to cram more and more into one building, you spread a single massive AI job across multiple data centers that could be hundreds of kilometers apart. But of course, there's a catch. There's always a catch, right? Scaling across creates a brand new problem. How in the world do you connect all these separate buildings so that they act like one single seamless supercomputer? Because if that connection is slow, your incredibly expensive AI chips just end up sitting around waiting for data. And that's a disaster. And this very challenge has kicked off an absolutely frantic, high-speed race between some of the heaviest hitters in tech to build the gear that can actually solve this problem. Really, the whole thing has boiled down to this epic three-way battle. In one corner, you've got Broadcom, an absolute titan in networking chips. In another corner, you have the king of AI itself, Nvidia. And stepping into the ring is the long-reigning champ of networking, Cisco. And things are moving at an absolutely insane pace. This whole competitive landscape basically appeared overnight. So mid-August 2025, Broadcom fires the first shot. Before anyone can even process it, Nvidia hits back just 2 weeks later with its own system. And then, early October, the veteran, Cisco, makes its big move. We're talking about market-defining launches happening weeks, not years apart. It's wild. So let's zoom in on Cisco's answer to this whole scale-across puzzle. They've built a system specifically for this job, and it's called the 8223. At the very heart of this thing is their new Silicon One P200 chip. And here's the headline number you need to know. 51.2 terabits per second. Now, to put that into perspective, that's like downloading over 1,000 high-def movies every single second. It is a massive fire hose for data, designed specifically to stop those traffic jams that can cripple these giant AI jobs. And what's crazy is that they've packed all of that power into what's considered market-leading density. So, in simple terms, they've squeezed 64 separate superhighways, each one an 800 gigabit port, into one surprisingly small box. And in a data center where every inch of space counts, that is a really big deal. But look, speed inside one building just isn't going to cut it for this scale-across thing. It's all about keeping that speed up over huge distances. And the 8223 is built to connect data centers up to 1,000 kilometers apart. So you could have a facility in one state and another one a few states over and make them feel like they're one cohesive AI supercomputer. Now, connecting stuff over those long distances brings up another issue. AI traffic is weird. It's often described as bursty. You get these huge, sudden floods of data, and then quiet periods. So to handle that, the system has what are called deep buffers. The best way to think of it is like a reservoir during a heavy rainstorm. It catches all that water, all that data, to keep the network from flooding and make sure everything keeps running smoothly. So here's the bottom line. Cisco's big bet is on this unique combination of features. You've got the deep buffering for that bursty AI traffic. You've got incredible power efficiency, which is a lifesaver in these strained data centers. It's programmable, so it can adapt to whatever AI needs next. And get this, it even has post-quantum encryption. That's security designed to fight off the code-breaking supercomputers of the future. Okay, so all that sounds great on a spec sheet, but what really matters is who's actually using it, right? Let's take a look at the real-world adoption because that's where the rubber meets the road. Right out of the gate, you have a massive endorsement from Microsoft. Their head of networking is basically saying that the chip's fundamental design is super flexible. It lets them use this one piece of tech not just for AI, but all across their cloud infrastructure, from inside the data center to the networks that connect them. Then you have Alibaba Cloud, and they're seeing this as a total game changer for their core network. They think it could let them replace their traditional refrigerator-sized routers with clusters of these much smaller, way more efficient boxes. I mean, that is a seriously disruptive idea in the networking world. And it's not just the huge cloud providers either. Major network operators like Lumen are also kicking the tires, looking at how this technology can boost performance for their own customers. That shows you there's really broad interest across the industry. All right, let's zoom back out for a second. What does all this mean for the future? Not just for this competition, but for the future of AI itself. Look, Cisco definitely has some cards to play. They have deep relationships with big companies, their Silicon One technology has been around since 2019, and they're flexible. But the challenge is huge. They're up against Nvidia, who can just bundle networking with its all-powerful GPUs, and Broadcom, the reigning king of networking silicon. It is a tough, brutal, fast-moving fight in a market that's still figuring itself out. And honestly, here's the real takeaway from all of this. This race is not going to be won by whichever company has the fastest chip or the most ports on a box. It's going to be won by the company that builds the most complete, the most robust ecosystem around their hardware. We're talking software, support, the whole shebang. So as we wrap this up, the question that's left is a big one. As AI keeps growing well beyond the walls of any single building, the battle for its physical backbone is really just getting started. This isn't a fight for the fastest chip. It's a fight for the entire platform that's going to define the next decade of innovation. So the real question is, who's going to build it?